Good morning, class. Hopefully you guys are excited to be here. As I said yesterday, I won't be in class with you. I'm helping out with the test. But I appreciate the substitute helping me out. Thank you very much. And I hope that you guys will listen, pay attention. And although I'm not there, it still is a learning day because we do have our quiz on Friday, just so you know, kind of my farewell gift to you for those that are on the good conduct trip. So as we get started, please open your books to page 457, where we'll be 457. And when you get there, your page is not going to look like the page that I have on the screen. In fact, this page is all the way back to page 101. Don't turn to page 101. Please turn to 457. But notice I'm all the way back in chapter 3, and we're going to do pretty much the exact same thing, except we're going to take it one step further. So back in chapter 3, we had solved these, and you're looking at these probably thinking, this is super easy, I know how to do it. That's good, because you're going to need that for today. So let's go through number 2, write these down and solve them with me step by step as we go. In fact, I want you to tell me the steps. Obviously, I can't hear you, but work these steps with me because these are going to be the same exact steps that we're going to see today. So number 2, our very first step is going to be, hopefully say or think, that you have to subtract 8 from both sides because we got to get the 2x all by itself to get the x all by itself. So we're going to subtract both sides by 8. So subtracting, I get 2x on the left-hand side of the equal sign. On the right-hand side, I get -4. So then 2x is equal to -4. Divide both sides by 2, and I get x is equal to -2. Number 4, first step is going to be subtract the 2 to both sides. So it's going to be t over 7 is equal to, now remember, -6 minus 2 is the same thing as -6 plus -2, which is -8. And then to get t all by itself, we multiply. Remember, we're doing the opposite. We do the inverse operation is a phrase that we learned. So here we have adding 8, so we had to subtract 8 to both sides. Here we had adding 2, so we subtracted 2, and then we have division here, so we multiplied both sides by 7. So we're going to do that same exact thing, but now if we were to zoom ahead in our books to chapter 11, you should be on page 457. We're going to do the exact same thing, but with radicals. Now, we have to remember, what is the opposite of addition? We asked this a couple of days ago. What's the opposite of addition? Your answer would be subtraction. What's the opposite of multiplication? The answer is division. So remember, we have these inverse operations. Well, what's the opposite of a square? Something squared. The opposite is the square root. So if I were to ask, what's the opposite of addition, you'd say subtraction. What if I said, what's the opposite of subtraction? You would say addition, because they're opposites. Well, if the opposite of a square is a square root, then what's the opposite of a square root? A square. So that's how we're going to solve. Remember, we would do inverse operation. So here, do we have x all by itself? Technically, no, because we have this radicand, this radical. So we have to get that to go away. How do we get it to go away? The inverse operation. What's the opposite of a square root? It's a square. So we have square both sides. We have to keep it balanced. We have to keep it even. Remember that video where the poor dude gets chucked in space? So you have to keep it even. So you square both sides. What do you get whenever you square it? You just get whatever's inside. Whatever's inside the square root is what you get. Notice up here you have x plus 3 is under the square root sign. Whenever you square it, what do you get? You get whatever is inside of the square root, x plus 3. So here, when we square it, we get what's inside, which is just x, and we square the other sign, which is 25. Now notice it says check, which you may say, do you really have to check? Well, look at example number 2 on page 458. Skill check 2. Example 2. It says solve and check. We're given square root of x is equal to -8. Now, if we do our formula, the inverse operation, we square both sides, we get what's inside, which is x. We square -8. -8 times -8 is positive 64. And you're like, 64 is the answer. But check your work. If you were to plug in 64, back in our original equation, if you were to plug in 64 for x, you would get square root of 64. The square root of 64 is 8, not negative 8. So it's actually a false statement here, which your answer means there is no number that will ever make this statement true. No number for x will make this a true statement. So your answer that we're going to put is no real solutions, like we see down here in skill checkbox. Number 1, that is put test, quiz, homework. This is what I want you to put, no real solution. Now, here's a little hint. Anytime you're ever told the square root of x, now it's just x inside. If there's something else inside, then it could still be we could actually get an answer. But if all you have is x on the inside of the square root and it equals a negative number, it's impossible. Your answer will always be no real solution. So if you look at skill checkbox number 1, I want you to do this with me. I'm going to tell you the answers really fast. But there's one of them that will have no real solution, and you should be able to spot it right away. Do you see what it is? Well, according to our rule, it's a square root sign with just the x inside that's equal to a negative number. Well, 1 doesn't check, 2 doesn't check, 4, all these numbers are positive. Look at number 3. So number 3 is the only one that will say no real solution. So I'm going to give you a bit of time. If you need more time, then the substitute can pause it if needed. But we're going to check our answers right now. Number 1, x is equal to 49. You square both sides, and you get 40. Number 2, square both sides, you get 2,500. Number 3, we already said was no real solution. It's impossible. And then number 4 is 144. Now, here's kind of, if you like to read, then here's the written out version of what I said. But it's just like what we did in section 3.3. But now we have to remember opposite of addition, subtraction. Opposite of square is opposite of a square root is a square. So look at example number 3. So if we didn't have a square root sign, let's forget the square root for a second. What we would do is we would subtract the 2 from both sides and then divide both sides by 3. But now that we have the square root, we have to get rid of it. But when do we get rid of it? Well, we have to get the square root all by itself. Right now, we have 2 terms. We have the square root of 3 times x, and then we have the 2. Remember, a term is separated by a plus or minus. So we have one term here, one term here. We have to get this to be the only term on the left-hand side. So I'm going to subtract 2 from both sides, which we get 6. So we're left with the square root of 3x all by itself is equal to 6. So how do I get the radical to go away? I square both sides. So when it goes away, I'm left with whatever is inside square root, which in this case is 3x, but I squared the other side, which is 36. Now I'll divide both sides by 3. I get x equal to 12. So does that check? Well, I'll plug it in. 3 times 12 is 36, where 36 is 6, plus 2 is 8. Yes, it does check. Now here, again, we want to get the radical all by itself, so I got to move the 6 over. Whenever I move the 6 over, I get the square root of 10 plus x, all under the square root sign, is equal to 1. Now I can square both sides. When I square the radical, all that happens is the radical disappears. I get whatever is inside, 10 plus x. And then on this side, 1 times 1 is 1. That's pretty easy. So now I want to get the x all by itself. So I subtract 10 from both sides. Here they wrote it vertically. We're used to writing it vertically. Here they wrote it horizontally. It's the same thing. They subtract 10 from this side, and they'll subtract 10 from this side. So you're left with x, and then 1 minus 10 is negative 9. Plug it in, and your answer is correct. Now sometimes, whenever you plug it in, do you see here we have our issue? Right away, the book stops, and they're like, whoa, 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 I know my rule. The square root of x is equal to a negative number. I know right away there's no real solution. Why try and continue? Why square both sides and then check? I know that there's no real solution. So I want you to do skill check box number 2. I'm going to do the same thing. I'm going to let you work it out, and the substitute can pause it, and then restart it here in about a minute or so, and I will tell you the answers, okay? So number one, you should get x is equal to 27. X equals 27. Number 2 is no real solution, because whenever you subtract 4 from both sides, you're going to get square root of x is equal to -3. Right away, you know it's no real solution. Number 3 is x equals 2. X equals 2. Number 4, x equals -4. -4. So it is possible to have a negative answer. But you'll notice we never get square root is equal to a negative number. We don't get that. Number 5 is, again, no real solution, because as soon as we move it over, we get the negative number. And number 6, x is equal to, this one was hard, it's 17.5 or 17.5. Either one would work. So 17.5. Now I do want to mention this paragraph about what the Bible talks about, beware false prophets. Why does the book talk about this? Because sometimes we'll have radicals that look like it'll be an answer, kind of like number 2. Like, oh, we got this. Square root of x is equal to -7. But beware, don't be tricked by it. I'll tell you, this is a number 1 mistake. And it reminds us of that scripture in Matthew, where it says, beware of false prophets, which come to you in sheep's clothing, but inward they are ravening wolves. You shall know them by their fruits. In other words, you as a Christian will be known by your fruits. And of course, anytime we hear fruits in the Bible, we're talking about fruits of the Spirit, right? So beware of those false prophets, those people that claim to be preaching Christ or to claim to be all about God. But you know them by their fruit, kind of like the way that we know radicals by checking our works. Same thing with others. We should check everything with the Bible. So let's check our work. Speaking of checking, let's check in practice. I'm not going to give you the answers to these in the video. In fact, what I want you to do is take out a piece of paper, and I'm going to collect this tomorrow. It's not homework, so whatever you don't finish. In fact, I'll have the substitute collect it for me so I know how much you get done in class, because I want you to be working. It's not a free time. So I'm going to ask if the substitute can collect this work once you finish. I'm going to give you these problems to do, and then I want you to see how much you can do. So on page 459, I want you to do 1 through 9, but the odd ones. So 1 through 9, the odd. And then on the next page, if you finish those, I want you to go 11 through 29, the odd. Now I know that's a lot of work, and you probably won't be able to finish them all. If you do, that's awesome. But I want you to get through as many as possible. If you have any questions, then go back to that work. You could even go back to the video if possible. It's up to the substitute. But do your best. I know you guys can do it. I'll come back tomorrow and I'll explain some more. But do your best. Again, we're doing the odds. So on 459, we're doing 1 through 9, the odds. And on 460, we're doing 11 through 29. Do your best, show your work, and I'll see you guys on Thursday, tomorrow. There is no homework for tonight since it is Wednesday. So again, this is not homework. Just try your best, all right? Have an awesome day, guys.